All right, you guys, let's get started. So 11.3 and 11.4 is on area of trapezoids and kites, and I think rhombus is in here too. So the first we're going to talk about is trapezoid. And so as a refresher, you'll have to know the formulas, but area of a trapezoid, which is what we have right here, if you want to make a little note, the area equals 1/2 base 1 plus base 2 times the height. So when we're talking about base 1 and base 2, we're talking about the two sides that are parallel here. All right? So it says we have an area of 36. We know that AD is 6 and BC is 12. So it says find the altitude. So the altitude is the same as the height. So that's our H value. So what we're going to do is replace what we know. We'll call this base 1, base 2. It does not matter which one's which. Replace base 1 and base 2 with those two values, and then the area with 36. So we're going to do our setup here. And from here, it's just a little bit of algebra. So I just wanted to go through a couple problems with you guys. As before, if you know how to do a problem, pause it and then fast forward to the answer, or just look at the answer key. And if you get stuck, come back to the video and see the explanation. So we're going to just work through this problem, using just some of our algebra skills here. 36 equals half of 18, which is 9. And then if we divide by 9, we get the height is 4. So that was pretty easy. Hopefully you could have done that on your own. The second one is the median. And so the median is when you connect the two midpoints in our trapezoid right there. And so the formula for the median, I don't know if this was on the formula notes or not, but it's the average of the two bases, and usually it's referred to as M. And so it's just the average, so half of base 1 plus base 2 is our median. So now that we know that base 1 is 6 and base 2 is 12, we just go ahead and take half of that. So that was half of 6 plus 12. So that's half of 18, so our median is 9. All right, the second problem that I wanted to go over was number 2. So I already graphed it. Take a second and graph it. So pause the video. Graph it on your own sheet. If you want, you can try this by yourself or follow along with me. So take a second and graph it really quick. All right, now that you have it graphed, we're going to go ahead and I accidentally cut out the actual question. It wanted us to find the area. So again, this is a trapezoid. If we look at it, we have these two are parallel. They have the same slope. And so in order for something to be a trapezoid, it has to have one pair of parallel sides. So we need the base. So the distance from -2 to 5 is 7. And the distance from our other base, we have -3 to 7, that's 10. And then our height vertically, so height straight down perpendicular to the base, is from -2 up to 4, so our height is 6 units. So we have everything we need. So we have area equals 1/2 of base 1 plus base 2 times the height. So let's go ahead and simplify that. And I'm going to keep simplifying. I'm going to do half of 6 because I know that better. Half of 6 is 3 times 17. And then if we do a little calculation, we have 51 units squared as our area. All right, moving right along, I'm going to go to this one, which I think on your worksheet, I think it's number 4. Hopefully you can verify that. And I wanted to go over this one and the next one because it deals with special right triangles. So for this one, obviously it's a trapezoid. So again, we're going to use our trapezoid formula. So I'm going to write that over here. 1/2 base 1 plus base 2 times the height. And we know that base 1 right here is 12. So how do we find base 2? Well, they've drawn in the height right here. And so what we're going to do is drop one more from this vertex of that trapezoid straight down perpendicular. So what we've just done is created a rectangle with one side is 12, and so the opposite side then is also 12. So right now we know that we have 6, 12, and we have to find this missing piece right here. So how are we going to find that? Well, we got a 45, 45, 90 triangle here. And so let's review a 45, 45, 90. The side across from 45 we each called W, and the side across from 90 we called W root 2. So right now we don't know any of these sides. So we have to figure out one of those sides to help us figure out the rest of it. So if we look over here, we have a triangle over here on the left, a right triangle, in which we know two of the sides. And so if we know our Pythagorean triples, we know that this is one of them, the variation of it. So we have a base of 6, a hypotenuse of 10. That means that our other leg should be 8, which gives us, the height is 8. And so if it's a 45, 45, 90 triangle, if one of the sides or legs is 8, that means that the other also has to be 8. And so there we go. We know our question mark. So now the entire base right there would be 26. So now we're just going to go ahead and substitute in our values and do some math. All right. If you guys do that, you get 4, that's half of 8, and we have 38, and 4 times 38 should be 152 units squared. Hopefully you got that. Again, the thing about this unit is there's going to be a lot of this review of 45, 45, 30, 60, 90, even right triangle trig where we use SOHCAHTOA. So I'm going to try to review those as we go through so nobody feels like they're stuck. I want you to look at the next one and try it yourself. And if you get stuck, refer to this video. Otherwise, just check for the answer. All right, hopefully you gave this problem a shot and got somewhere. I don't know. If you didn't, then that's okay. Also, I'll go through it with you, and we're going to get through it together. So this problem gives us one length, 12, and a lot of angles. And so my guess is we're going to use some type of 30, 60, 90 in this problem. So over here on the side, I'm going to put a review of our 30, 60, 90. And remember, it doesn't necessarily always have to be in that order with the 30 and the 60. They could be reversed, but essentially it's the same idea. So the side across from the 30, we refer to W. Side across from 60, we said was W root 3, and the side across from 90 was 2W. So, like I said, I'm guessing we're going to use that to help us find some of these lengths here. And so let's see what we can figure out. We need base 1, we need base 2, and we need the height of the trapezoid. And so let's see if we could figure this out. Since we only have this value of 12 here, let's use that. So let's draw this height also. That's 90, that's 60, and so that means that the remaining angle, why do I keep writing 36? 30. So here we go. We have a 30, 60, 90. We know the side across from 90, the hypotenuse is 12. 12 is equal, if we refer back to our original 30, 60, 90, is 2W. So if we solve that, W 6. Oh, look at that. So now we know the side across from 30 is 6, and the side across from 60 is 6 through 3, root 3, which is the height of our trapezoid. So now we're going to just transfer that across here as 6 root 3. All right, so now we have another 30, 60, 90 over here. It's 30 degrees. Okay, we got the side across from 60 is 6 root 3. So up here I'm going to say 6 root 3 equals, if we refer again back to our original 30, 60, 90, we have that equals w root 3. Get w by itself, so we divide by root 3. And in this case, both root 3's divide out to be 1, so w is 6. So now let's use 6 to get the rest of this left side of the trapezoid. So side across from 30 is 6. Side across from 90, let's see, we need 2 times 6, so that's 12. And so now, I'm going to erase some of this work up here. I believe we have enough. So let's see. They told us that these two are congruent, so if the hypotenuse of that left side is 12, that means that this base is 12. Which means when we went ahead and dropped our altitudes or our heights, we've created not a triangle, a rectangle. And so if the top is 12, that means this is 12. So now let's do a little addition here. 6 plus 6 is 12, plus that 12 is 24. And now I think we have enough. The area of this trapezoid is 1/2 of base 1 plus base 2 times the height, which was 6 root 3. So we have area equals 1/2 of 36 times 6 root 3. We have 1/2 of 18. Oh, not 1/2 of 18. 1/2 of 36 is 18. If I were in class right now, you guys would totally call me out for that one. And then we have 18 times 6, which is 108 root 3. So this would be exact right here. If you guys are taking a quiz or doing like a quizzes or something like that, and I couldn't give it as an option to put the root 3, then I would just leave it as a decimal. So we'd round that. I don't have a calculator with me, but you'd type that in and round it probably the nearest tenth. So that's question 5. I believe I have one more question, and it's going to be number 8, I believe. So hold tight. All right, last one, number 8. Thanks for your patience. Hopefully you guys are doing okay through this. After this one, I would just ask that you guys complete the other couple practice problems. And let's see what we have here. Find the area of a rhombus inscribed in a circle. So let's see. See my skills at drawing a circle. Not bad. It says we have a rhombus inscribed in a circle. Gosh, how the heck are we going to draw a rhombus inside a circle? Because that doesn't work. Ah ha ha ha. I believe we learned that if we have a parallelogram inscribed in a circle, then it has to be a, what'd you say? A what? A rectangle. And so, since a rhombus is a parallelogram, and a parallelogram inside a circle, inscribed in a circle, must be a rectangle, what do we call a parallelogram that is both a rectangle and a rhombus? Yell it out. What is it? Yell it. Yell it loud. Square. You can tell I've been locked up too long, huh? So really we have a square here. Very interesting. And it says one of the diagonals in this rhombus, which we really know is a square, is 10. So if we think about the properties of a square, diagonals are congruent, so we know each of these diagonals are 10. Now, there's a couple ways you can do this. You can try to figure out the base and the height, and then find the area, which wouldn't be too bad. So if one diagonal is 10, that's the side across from 90. And in a square, when you draw that diagonal, you create a 45, 45, 90 triangle because the square has congruent sides. So if we know that the side across from 90 is 10, we can set that to w root 2. divide by root 2. I'm going to go over here to simplify. Now, if you remember, we can't leave a root 2 in the denominator because it's improper. So we're going to simplify. Square root of 2 times the square root of 2 is the square root of 4, which is 2. When we simplify, reduce this, we're left with 5 root 2. So each of the sides of the square is 5 root 2. Area of a square is the side squared. So when we have 5 root 2 squared, really that means 5 squared times root 2 squared. So we have 25 times root 2 squared is 2, so we have 50 units squared. That's one way to do this. So that's using the idea that the area of a square is a side squared. Let me show you, some of you guys might like this other way, so I'm going to erase this really quickly. Show you one other way that we can do this. It's without using 45, 45, 90. It's using the idea that we have a rhombus here. So let's see what we get. Area of a rhombus. One half diagonal 1 times diagonal 2. I believe that was on the formula sheet. So this is a little shorter. It's the area of the rhombus is 1/2. We know one of the diagonals is 10, and because this was a square, the other diagonal is also 10. So we have 1/2 of 100, which also gives us 50 units squared. You know, I really hope you guys liked this video. I know it got a little bit long, but like I said, use this as you need it. Don't just watch the whole thing for the sake of watching the whole thing. Try the problems on your own, and when you get stuck, use this video as a resource for you. So hopefully you guys enjoyed this. What I'm going to ask is that you complete the rest of the practice for this, and then check Schoology for what else I'd like you to do today. I hope you guys are doing great, and enjoy the rest of your day. Bye-bye.